Hello and welcome back. Today we'll be looking at section 10.2 on the parabola. You may have noticed we skipped 10.1. 10.1 is literally one page long, just showing a couple of quick diagrams on what conic sections look like and telling you the names. I don't really see a need to do a separate section on that. As I said, it's literally one page long and there's no homework attached to it. And we'll be going over the different conic sections in detail in the various sections we cover in chapter 10 anyway. So the parabola. You've seen parabolas before. Now that you're in trig, we look at a geometric definition for parabolas. So parabola, set of points P. We're working in a plane. Same distance D from a fixed point F that we'll refer to as the focus. As they are from a fixed line. Known as the directrix. Midpoint of the focus and directrix is the vertex. So we'll derive one of these and just sort of build on that one. So we're going to work without loss of generality. Let the vertex be on the origin. So this is saying it's not going to change how these values relate to one another. It's just going to make the math of the derivation a little bit simpler. So we're also going to examine one that opens up. As you know from your 165 work, parabolas can also open down. They can also open left or right. We're just going to examine one centered on the origin, opening up. Vertex at origin, opening up. So here's just sort of a quick rough sketch. So here is our vertex on 0, 0. We're opening up. Here's some point P at location X, Y. Here is our focus. And we'll call the distance between the vertex and the focus, we'll call that A. So that means the location of F is at 0, A. And then our directrix. A units the other way, so Y equals opposite of A. So let's call this distance 1. And we'll drop a nice pretty perpendicular there. And this will be our distance 2. So distance 1 is equal to distance 2. Distance 1 square root of change in x squared, so x minus 0 squared is x squared, plus change in y squared, y minus a quantity squared. Distance 2, distance between the line and point P. Well, the place that this perpendicular lands, x coordinate is still just x since we went straight down, and the y value, as you recall, hopefully is opposite of a, so distance 2 then, x's are the same, so this would just be a y plus a. So remember, by the definition, all of these points are equidistant from this fixed point and this fixed line. In other words, distance 1 is equal to distance 2. So square root of x squared plus y minus a quantity squared is the same as y plus a. So we'll square both sides of that, and we'll say that x squared plus y minus a quantity squared is y plus a quantity squared. So we squared both sides of the previous line. So if we get that x squared alone, we have x squared is worth y plus a quantity squared minus y minus a quantity squared. Notice we have a difference of perfect squares here, so we can factor that. So x squared is y plus a plus y minus a by y plus a minus y minus a. So just sort of the form of u squared minus v squared, u plus v by u minus v. So x squared is now, notice the plus a and minus a are going to drop, so we have 2y left in our first set of grouping symbols. And then in the second one, the y's drop out. A minus a negative a is a plus a, 2a in the second pair. So x squared would be worth 4 times a times y. So this is sort of the basic format for a parabola centered on the origin that's opening up, with the focus a units away from the vertex and the directrix a units down from the vertex. Now, to sketch a graph, it's also helpful to find points to the left and the right of the focus, or up and down from the focus, depending on which way your parabola is going. Those 2 points that are in line with the focus form what's called the lattice rectum. So if we keep our equation from before, our x squared is worth 4ay, we can let y equal a. Then we can say x squared is worth 4a squared, so x is plus or minus 2a. So then that is one more pair of points that we would have. So the focus, if you'll recall, we were moving up to 0A. So now we have points at negative 2A, y is still A, positive 2A, y is still A. And the line segment connecting these is the lattice rectum. Usually abbreviated to LR. Alright, so let's put these to work. So let's say we have something of the form x squared is worth 12 times y. So I want it to look like the previous problem. So I want to factor out a 4 and then see what's left. So 4 by 3 times y. So here a is worth 3. Our vertex, since we look very much like the previous, is still on the origin. If a is positive and we have the x squared alone, this opens up. If we had an x squared but a was negative, we would open down instead. So opening up means the focus is going to go up by 3 units. So our focus for this one is on 0, 3, which means our directrix is at y equals negative 3, drop 3 units down. And our lattice rectum endpoints, so recall that we ended up with using an absolute value of 2a, so 2a here would be 6. So we would go left and right 6 from the focus, so negative 6, 3, positive 6, 3 are the endpoints of the lattice rectum. So that's enough information to draw just a quick sketch. So our vertex was on the origin. Focus on 0, 3. Directrix at x equals negative 3, so I'm just going to draw a dashed line. Dotted line, dashed line, whatever you care to call it. And then we're going to go, again, 6 units left and right from the focus. So 2, 4, 6, and 2, 4, 6. So we go through the vertex and the 2 points at the end of the lattice rectum. So the lattice rectum is just the line segment connecting those two guys with the focus in the middle. So next up, we'll take a look at y squared is negative 8x. So notice this time we have a y squared by itself, so y squared instead of x squared, so our options are either to open up, we did opening up and down, so opening either left or right. Again, I want to take a factor of 4. So that would leave my a at a negative 2. So the negative direction indicated by the A value being negative, tells me that this is going to open left instead of right. We haven't done any shifting of the x's or y's, so our vertex is still on the origin. Our A value has absolute of A is worth 2. So our focus, we're going to move left 2, so -2, 0. Our directrix, I would then go to the right 2. So that would take us to x equals +2. So the directrix, it depends on which one you have by itself, if you have a vertical or horizontal directrix. Is it an x squared or is it a y squared? And our lattice rectum endpoints. So 2 times A here, 2 by -2, -4. So we're going 4 units out from our focus. So the x is going to stay at the -2. I'm going to go 4 units up and 4 units down. And that's enough to make our sketch. So vertex is still on the origin. Focus is at -2, 0. Directrix at x equals +2. So a nice little dashed line there. And then 2 times A, -4. So I'm going to go 4 units up and down from the focus. And those form the endpoints of the lattice rectum. And we just connect with a nice smooth curve. Now, if you'll recall, though, graphs can always shift. We can always shift left or right or up or down. Now, the shifting doesn't work any different just because we're working with these conic sections. So this next one, we'll take a look at x minus 3 quantity squared is worth 4 by -1 by the quantity y plus 2. So we have an x squared, so this is either opening up or down. That we know just because we had an x squared involved. The fact that a is a negative tells us that we are opening down on this. Our vertex, though, is no longer at 0, 0 as it would if we didn't have this -3 in here or this +2 in there. So a -3 inside with the x shifts us to the right 3. So in other words, to get to where a 0 used to be, I need to plug in a +3. To get the y to where a 0 used to be, I'd need a -2 in there. So we shifted to the right 3, we shifted down 2. So now we have a vertex at 3, -2. Now our a value is a -1. So our focus, remember we're opening down, so we'll move down 1 unit from the vertex. So that means that the x stays the same, the y moves down 1. So 3, -3 is where our focus is. Directrix, we would move 1 the other direction, so 1 unit up from there is at y equals a -1. And then our LR endpoints, 2 times A in absolute value here is 2, so we're going to move 2 units away from the focus. Because we are opening down, that means we're going to be moving left and right from the focus. So left 2 units from there would put us at a 1. Y value would stay the same. Right 2 units would put us at a positive 5. Y value still the same. And that's enough to make our sketch. So same idea, we just did a little bit of shifting work. Yeah, that one's reasonably close to straight this time, hot dog. Alright, so our vertex, instead of on the origin, we're at 3, -2. Focus is at 3, -3. Directrix y equals -1. Last rectum endpoints, we're going to move 2 units left and right from the focus. 2 this way, 1, 2 that way. So we connect that with a nice, pretty smooth curve. So now I'm going to suggest that you try this next one on your own. I'm going to put it up and ask you to pause it and give it a spin. So see if you can sketch out y minus 4 quantity squared is worth 4 by 3 by the quantity x plus 1. So find all that pertinent information. Okay, welcome back. So our shifting, the y shifted up 4, the x shifted left 1, so we're at -1, positive 4 for our vertex. A here is 3, and we had a y squared. So if it's the y squared, we're either opening left or right. The fact that A is positive, we're going to open in the positive direction for the x's, which is to the right. So that means our focus, we would move to the right 3 units. So from -1, that would take us to a positive 2. Y value would remain the same. So directrix, I would move to the left 3 units. So that puts us at x equals -4 for the directrix. Minus rectum endpoints. Absolute of 2a here is 6. So 6 units, in this case up and down from the focus. So 6 units up from the focus puts us at 210. 6 units down from the focus puts us at 2, -2. And that's enough information to sketch your nice pretty curve. Okay, so our vertex was at -1, positive 1, 2, 3, and 4. Focus at positive 2, 4. X equals -4, our directrix. And at 210 and 2, -2, we have the endpoints of our lattice rectum, the line segment connecting these two guys. So hopefully your curve looked something like that. Now once in a while we get to resharpen our skills with completing the square. So just like in your college algebra days, we still get to play with that. So the next one we're going to work with is y squared plus 6 times y minus 4 times x plus 1 equals 0. So we have a y squared, so I'll keep all the y stuff on this side. I'll move the other stuff to the other side. And then we'll just complete the square. So we'll add 9 to both sides. So left side, I now have a y plus 3 quantity squared. Right side, we have a 4x plus 8. In this new geometric method, a little bit different than what you did in your intermediate algebra and college algebra days, we factor out a 4 and figure it out from there. So here, our a value is 1. We have a y squared, which means either left or right for our opening. A is positive, so this one opens right. Our vertex, the x shifted to the left 2, the y shifted down 3. The fact that we're opening to the right means we would go to the right a units from the vertex. So to the right 1 unit would put our focus on -1, -3. Moving to the left 1 from the vertex, we form a line for the directrix of x equals, we're moving, let's see, to the left 1, so that is at -3. And our lattice rectum endpoints, since this one is opening to the right, we're going to move up and down by 2a. So absolute of 2a in this problem is just a 2. So from the focus, we will go 2 units up, 2 units down. So that means the x stays at -1, 2 units up. Our y is at -1. X stays at -1. 2 units down puts us at a -5. And you can sketch the graph from there. You've seen a few of those in a row already of how to sketch it from there. Alright, so I would recommend in 10.2 to try out 13 to 63 on the odds. And again, I'll try to create a similar assignment for you, my Math Lab fans. If you have questions, please get in touch. Otherwise, I'll see you next time. Stay safe out there.